Hi guys, next I have an integration question for you guys. If integral square root of 1 plus sine x multiplied by fx dx is equal to 2 by 3 1 plus sine x to the power 3 by 2 plus c, then what is fx? We need to find out what fx is. Our options are cos x, sine x, tan x, 1. Well, you can also actually directly, if you know integration, if it strikes you, then you can probably directly also answer this question. That if you take fx as, you have certain options with you. If you take, say, fx as cos x or sine x or tan x, what kind of substitution will give you that result? Or else what you can do is, you are given that integral of square root of 1 plus sine x fx dx is equal to a certain value to the power 3 by 2 plus c. If you differentiate on both the sides, you need to know that d by dx and integral dx, they are entire of each other, they are inverse of each other. So when you integrate, when you differentiate an integral, you get the function itself. So which basically means if I take d by dx of this entire integral 1 plus sine x fx dx, I'll be taking integral on both the sides, because I'll be taking the derivative on both the sides, because we have equality here. So you'll be taking derivative on both the sides. Now, when you differentiate an integral, whatever is inside the integral comes out as it is. And since these are indefinite integrals, they are not definite integrals, so bounds also do not make any difference. So you will have 1 plus sine x square root of that fx on the left hand side, and on the right hand side you can differentiate this. So differentiating 2 by 3 as it is, then the power 3 by 2 comes in, 1 plus sine x 3 by 2 minus 1, and c, for c the derivative will be 0. So what you get is, you have 1 plus sine x square root fx is equal to, this cancels off, and you get 1 plus sine x 1 by 2, but do not forget the chain rule here. So 1 plus sine x, you will have to differentiate that and you will get cos x here. Okay. So cos x is something that will come in there. C, the derivative will, be 0. So you just get cos x here, which means that the two sides can only be equal when it's exactly the same. So that means this fx is nothing but cos x. This is something that you could have directly from the options also seen, because if you would take fx as cos x, then you can easily make the substitution and integrate, and this is the answer that you will actually get. So cos x is the correct answer here. Let's find the integral of 1 upon x into x to the power n plus 1. Is it 1 upon n log x to the power n upon x to the power n plus 1 plus c? Is it 1 upon n log x to the power n plus 1 upon x to the power n plus c? Is it log of xn upon xn plus 1 plus c, or none of these? Okay, so let's just try to figure it out, what it would be. What I'm going to do here is, you have integral 1 upon x to the power n plus 1 dx. So you should be using some kind of manipulation out here. Now, what manipulation would we use? I can see xn in picture. So let's make this x that you have in the denominator xn. And how will I be able to do that? If I multiply numerator and denominator by x to the power n minus 1, I'm going to get xn here. And here I have xn plus 1. Now, with this, what has happened is I have x to the power n in common as such. So, what I can do, I can now make use of substitution. Let's take x to the power n as t. So, n x to the power n minus 1 dx will become dt. And let's make use of this substitution. So, which gives us our I, let's call this integral I becomes dt upon, so we have x to the power n minus 1 dx as 1 upon n dt. So, n in the denominator here, or 1 upon n dt. And here I'm going to have t plus 1. So, integrating this, 1 by n can stay outside, and I have dt upon t plus 1. This I can even break it. We can break it as partial fractions. So we can take 1 upon t into t plus 1 as a upon t plus b upon t plus 1. And that's going to give us a as a as 1, b as minus 1. So using partial fractions, what is happening? I can say that integral 1 upon t plus 1 dt is nothing but integral 1 upon t minus 1 upon t plus 1, the entire dt. So integrating this, which is equal to integral 1 upon t dt plus integral 1 upon t plus 1 dt. Mind you guys, do not forget the 1 upon n later on, okay? So right now, I'm just concentrating on this part. But yeah, there is 1 upon n. So I'm going to call it I1. So I1 is this. And it is basically log t, natural log t minus natural log t plus 1. Right? So this becomes natural log t upon t plus 1 plus c. So what we have is I will be equal to 1 upon n log t upon t plus 1 plus c, which means it is 1 upon n, t is x to the power n upon x to the power n plus 1 plus c. Well, do we have any such option? 1 upon n, x to the power n upon x to the power n plus 1 plus c is A option. So A option will be the correct option. Next, we will discuss if integral gx dx is equal to just the function gx, then integral gx multiplied by fx plus f dash x dx is equal to. And we have the following options. Gx fx minus gx f dash x plus c, or is it gx f dash x plus c, gx fx plus c, gx f square x plus c. See, many a times you can look into the options and actually find out, take the calculated risk or logically deduce that, okay, this would be the correct option. In CUET, since there are too many questions that they are asking you, so I expect questions which are like 2-3 step questions. Some questions which would be very lengthy questions, they would be the questions that you should be attempting at last, because you should optimize on the time. You do have a time constraint. Okay, so remember that maximize your correct, maximize your correct ability to mark correct answers, basically. So for that, pick your questions correctly, even if they are small questions. It's all that matters is you scoring. Which question is giving you that score, that doesn't really make any difference. Okay. Okay, so what would be the correct option? So in this question, we are given that integral gx dx is just gx and fx is some function. It is, we don't know what function it is, but it's just some function. Integral gx dx is just gx, and we are supposed to find out integral gx multiplied by some function fx plus its derivative. So what would this be? If you open this up, this is equal to integral gx fx plus integral gx f dash x, right? It's basically an application of by parts. So what we can say is this integral gx fx, if I take fx as first and gx as second, first as it is, fx as it is, integral of gx dx minus the whole integral derivative of first, which will be f dash x, into integral of the second. So integral of this entire thing. Plus, I'm not touching upon the second term, which is gx f dash x dx. Why I'm not doing that? It's for a simple reason. So you have fx gx, because integral gx is just gx, minus, again, integral gx is just gx. So this is f dash x gx dx. Plus, if you observe, it's the same term, integral gx f dash x dx. So these two terms cancel each other out. And what are we left with? We are just left with plus c. Don't forget plus c. So it's just fx into gx plus c, which should be the correct option. And this all is happening because you are given that integral gx dx is nothing but gx itself. So it's a purely application of by parts. Let me just make you guys write down by parts once. So you have integral of first function, second function. If you have to integrate that, it's first as it is, integral of the second, minus the whole integral, derivative of the first, into integral of the second, the whole integral. This is what is the formula to by parts. Okay. And then by the rule of Eiler's, you decide which should be the first function, which should be the second function. And accordingly, you work it out whenever you have to take the integral of a product. Okay. So the correct option is option C. Clearly, option C is the correct option.